straightforward for you all. It's just a reminder that if you're asked to graph any kind of function, you can do so by having a table of values. Sometimes the question will give you a table of values and you then plot them as coordinates. Other times they'll just say, just do it. Okay? So this is just a quick look and an introduction at looking at different types of functions as well. So we choose values of x, substitute into the given equation, and to find values of y. These then provide us with coordinates that we join up. Alright, so here we go. Draw the graph of these equations. You will notice on the following pages we've got lots of axes, so we don't have to draw them. But we do have to set up our table of values. We're going to do that for all of them first. So when I say table of values, they specifically asked us to have the values of x from -3 up to and including 2. So you draw yourself a little table. You write -3, -2, -1, 0, 1, and 2. Now, bare minimum when you're drawing these graphs is to choose 3 coordinates, or 3 points. For fancier graphs, like things like this, where you've got x squared and x's and x cubes, I would suggest to choose a few more points. Okay? So for a straight line, it's minimum 3. For any of these fancier ones, you probably want a few more coordinates. And always make sure you've got 0 as one of them, because then that shows you where it goes through the y-axis. Then what we're going to do is in our calcs, because we'll have them available to us, is stick these numbers or substitute these values of x into this equation here, one by one. Because this is our rule to find y. So to find what should go into this box here, we are going to substitute -3, square it, add -3, and add 2 to it. Now when you're putting into this into your calc, you need to make sure that your negative values go in brackets. And in fact, if you do this, let me see if I can get a calculator to show you. Right, let's see if we can do this then. So when we're doing this, we're going to open up a bracket. Our first one is -3, correct? Why is it not working? All right, so it's -3 squared. What was it then? Plus -2? -3. Oh, yes. And then plus 2. Okay, so we press enter and we get the value of 8. Okay, so if we want to copy what we've just done, we just arrow up. If you can see, I'm using my cursor and it highlights it. And then like a computer, you will Control C and then go down to your space and Control V and it pastes it in. Okay? And then you can just change the value that you had, so it's then -2.
That's so cool.
And enter, and then you can just Control V again, because obviously you don't need to keep copying it, you've already got it. And you can find all of your values. Right, okay, so we've all done this, other than Shayna, because she's setting up a base count. What values have we got? 8, 4, 2, 4. Okay, so that's our first table. We're going to do all our tables and then we're going to start to draw them all, okay? I think that's the best option. So then this rule here is obviously x cubed plus 3x. They've asked us to do it from -3 to 3, so our table has x, y, -3, -2, -1, 0, 1, 2, 3. Okay, who just said that? We've just done a whole topic on inequality.
No. I was wondering why there was another one there, and I was looking. I know what inequalities are. I'm sorry.
Alright, so we're checking we've got the same values. What did we get here? -2.
Negative
I know. Alright, say again. Oh, hey, I think just one person and then we go get 4.
Oh, yeah, -4, then 3. Okay, so we're making 0. We're making a point stand.
No.
Why is 4?
Alright, okay, so we've now got all of our values. And now we can go ahead and draw these. Note that the 2 gaps are where they were undefined because we were dividing by 0. So we don't put any values. It's not 0, it's undefined, so we leave a gap. So we've got our set of axes. Now the reason that I've got you to, I've just left the axes blank is because you sometimes need to decide on your scale. Sometimes it's a question they will tell you which scale to use. Otherwise, you need to decide. For this one here, oh sugar. For this one here, it's pretty fine. You've got x values from -3 to 2, and you've got y values that don't go to the negatives, they go up to 8. So you should be okay to choose yourself a set of scales for that. This next one goes from -3 to 3 in the x-axis, but they go from -36 all the way up to 36. Now you may say to yourself, do you know what, I'm just going to ignore these ones. I'm going to get the gist of what the graph is going to look like without plotting those, which makes it a lot easier to do. But if they've specifically given you this range, you do need to include it, okay? So when it comes to those ones, you need to get your set of axes and say, right, how am I going to fit that on here? And it's one of the hardest things that people find when they're trying to draw a graph is what scale should I be using? And as someone is not always going to tell you, you have to use your common sense to choose the scale. So you have a look at this and say, right, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares going up, and I need to represent 36. So it might be that you want to go every 4. Okay? And then you just need to recognize that if this one square is worth 4, then obviously halfway would be representing 2, 1 would be at 1/4, and 3 would be at 3/4. But you are looking at the values that you need to represent, looking at the graph that you have, and you choose that set As you may or may not recall, I did say that if this is the scale that we've chosen to use for our y-axis, it doesn't mean that we have to use the same scale for our x-axis. So you can have, this is 1, 2, 3, 4, -1, -2, -3, -4. You can have different scales on your x and your y axes as long as they are uniform as each other. Does that make sense? Yeah. You know. So this has to be a uniform scale, this has to be a uniform scale, but they don't have to be the same scale as each other. Okay?
Do you have to say it's only in the positive for one axis? Do you have to write the negative?
No, you don't. Now, and I just found these graphs somewhere to chuck them on to help you. So you don't need to label underneath if you would normally do it.
Oh, wait. Okay.
So for example, as you say, the first one, there are no negatives, so secretly you probably wouldn't include this in your diagram. Okay, so you don't need to label that. Okay?
If you want to, could you use the bigger graphs or the ones that go further? Because after you magnitude, it's like a more useful.
I think I put this one on because we start getting into decimals, I think. Oh, yeah, then I included that one. Or they're humongous numbers. Yes. So it was decimal. I think I've given you enough graph paper. If I haven't, I apologise. So think about your scales now. What items should you be using to draw these? No, not a ruler. What should you be using? A pencil. Okay, you'll see why not a ruler in a minute. Now, you would only use a ruler when you know that they are a straight line graph. We all know what formats do straight line graphs come in. Ready?
Straight line graph has a format of y equals mx.
Okay, y equals mx plus c. So our highest power of x is just 1. Do we have any of them that look like y equals mx plus c? C. No, so none of these are going to be straight lines, so you're definitely not using a ruler. So what I want you to do now, choose your scales, plot them as coordinates. So you're then plotting this, so if you were going to draw this graph here, you would plot the coordinate -3, -36. You would then plot the coordinate -2, -14. Now, I'm not hoping I'm not having to remind you how to plot a coordinate. If you're plotting -2, so if you're plotting -2, 14, you find those two numbers and where they meet, you're going to put a dot. Okay, that's how you plot a coordinate. So you're just plotting lots of points for now. Okay, in pencil, in case you mess up, and even labeling your axes in pencil. Please, remember that when you are labeling your axes, you start from the middle. Okay, so start at 0 and work your way out, because otherwise people make silly mistakes and then it will go horribly wrong. Okay, so I'm going to leave you to plot all your points, and then we'll come back and see what they look like.